Hey everyone, this is number 3 from the 2019 free response exam. This is the no calculator section, and there is already a video for part A, but this is part B. So I will not read the question to you again. I'll assume that you watched part A. You could take a look. You have a graph of f, and part B is asking you to evaluate the definite integral from 3 to 5 of 2f prime of x plus 4 dx. If you want to pause and try this, feel free to do that. One thing we know we can do with our integral properties is because we have a sum. If this helps you, you are allowed to write this sum as 2 different integrals, which would look like that. Again, if you want to try to pause and find these antiderivatives, you can go ahead. We are not going to use area under the curve right now because this is the graph of f, and we have f prime in our integral. So I'm going to start with the fact that we have a constant of 2 and move that out. We know that that is one of our properties, that we can move the 2 to the outside, and then we're going from 3 to 5, f prime of x dx. And on this next step, we'll find our antiderivatives. Again, you can pause and try to find those. The first one, so we have our 2 that move down. You're trying to figure out what is the antiderivative of f prime. It's been a while since we've seen this. Antiderivative is f because the derivative of f is f prime. So we would have f of x, and then remember the integral sign goes away, the dx goes away, and we have our bracket 3 to 5. And we have a plus sign. We're trying to figure out the antiderivative of 4. Okay, antiderivative of 4 is 4x because the derivative of 4x is 4. So that antiderivative is 4x. Integral sign goes away, dx goes away, and we have our bracket from 3 to 5. Okay, then we are ready to plug in our upper limit and plug in our lower limit. And remember that we subtract. So we have 2 f of 5 minus 2 f of 5 minus 2 f of 3. Great. Then we'll go over to our second antiderivative over here, and we're plugging in the 5, and we're plugging in the 3, and we're subtracting. I'm going to erase this just so you can see that clearly. Okay, so we plugged in the 5 and the 3 to the first antiderivative and subtracted. We plugged in the 5 and the 3 to the second antiderivative and subtracted, and this plus sign moved down. The last part of this is just to evaluate. So I have 2 f of 5. Think about where we're going to get the value of f of 5. I'm going to go ahead and grab a copy of that for you. That is the graph of f. So f of 5 means to go to the f graph, look at 5, and take the y value there, or the output. So when the x value is 5, what is the y value? The y value is 0. Minus sign, 2 f of 3. Again, f of 3 means go to the graph of f, go to the x value of 3, and figure out what is the output there. We have a weird output, and if you remember from the question, it said that it is known that the point 3 comma 3 minus root 5 is on the graph. So that's why they gave us that weird piece of information, 3 comma 3 minus root 5. So that point 3 comma 3 minus root 5 is a coordinate, and so that means the output there is 3 minus root 5. Just making sure I copied that right. Okay. Then we have 4 times 5, which is 20, minus 4 times 3, which is 12. You would technically be able to stop right there. So if you like kind of just leaving it unsimplified, you would be totally finished and you'd have full credit on this one. If you wanted to keep simplifying, you have a negative 6, you have a positive 2 root 5, you have a positive 20 minus 12. So that's distribution. You can combine those like terms. Negative 6 and 20 is 14. 14 minus 12 is 2. This is all without a calculator. So if you are worried about not getting that right answer, I would encourage you to just stop right here and not do any simplifying. So that is it for that question. The rubric is right here. So you got a point for the FTC, which was the antiderivatives, and then a point for the answer. And I am just repeating that you are allowed to stop there if you wanted to. And our answer looked a little bit different when we got to that point, but ours was right. You can see the final answer here. Okay, and then if anyone is interested, this second solution method, they just did not write two separate integrals. Remember on our first step, we split it here into two separate integrals using that summation property. This solution method does not do that, and you might like this. So they just carried the 2 over as a constant. They said the derivative of f prime is f of x. Sorry, the antiderivative of f prime is f of x, and the antiderivative of 4 is 4x. So they kind of just left it as one integral there, and then they did their bracket 3 to 5, and you can see this is them plugging in the 5 minus sign. This is them plugging in the 3, and they did all their work similarly to what we did and got the same answer. So if you prefer that second method, you can go ahead and try that and see that you get the same answer. All right, that's it. Great work.